Our team designed a multifunctional earpiece that is catered towards the mental and physical needs of athletes on Mars. Our earpiece has four main functions, the first being a communication device, allowing sound to be transmitted wirelessly, and thus the athletes can communicate with each other as well as the organizer. Our second function is a fitness tracker. The fitness tracker allows athletes to keep track of their heart rate, how much sun they receive, and etc. The third function is a translation device. Athletes gather from all over the place to participate in sporting events at the Olympics. Thus, the translation device allows athletes from different countries to communicate with each other. Finally, the fourth function is the music listening function, because music helps improve the mood of the athlete and thus improves the mental wellness of these people. Though we could not interview Olympic athletes on Mars, we were able to get some user feedback from our local college campus on the use of headphones and fitness trackers. 100% of our participants said that they own a headphone or an earpiece, and almost half of them said that they use them several hours a day. About 30% of our participants said that they own a fitness tracker. And one of the most notable comments is that, "I don't own a fitness tracker, but I would like one. If it were the same as my headphones, that would be a super convenient and a worthwhile investment."
We created a matrix for specific user input when thinking of the design of the earpiece. We had 3 different designs in which we shared with them, and which had specific features and wearability to rank basically which one was the best model for our users. They ended up choosing the earpiece model that goes around your ear, and that was the one with the highest rating and the one we decided to move forward with. So in our final design, we have an earpiece that looks something like this. The final model would have basically a light sensor, a heart rate sensor, that kind of measures your sleep patterns or just your heartbeat. And how this model works is it goes over your ear and around your ear like this. This is pretty simple and easy to use for people, everyday regular people, when they're walking around, when they're at work, or for people who are working out. So we started off by scanning each other's ears, our teammates' ears, and to be able to model off of that. And I ended up 3D printing an ear out in which I could model with. But in addition to that, I also cut out little pieces of paper that were pretty rough and could go around the ear that looked something like this, and tried fitting them on my teammates' ears. With many designs, I went through about 10, 15 different designs. I found the perfect fit and started sketching that out on SolidWorks. What came of the SolidWorks model was this design, which I 3D printed and is our model for our earpiece. This doesn't have the buttons and the sensors on it, but what we are trying to do is to combine everything into this earpiece.
The earpiece will be entirely wireless and will be connected to the internet and laptop. All the sensors are first tested on Arduino and Ethernet shield. Arduino connects all the sensors to the laptop, and Ethernet shield connects the Arduino to the Wi-Fi. When the earpiece is on, data will be collected and transmitted to a database. Then the database will be connected to the app on the cell phone. Python and JavaScript is used to connect our design to the database, and SQL will store our data. We also use a local server environment called XAMPP, which allows us to connect our sensors to the local host and also to the Wi-Fi.
We want our product to go hand in hand with a mobile app that will create a complementary and interactive experience for the user. After connecting the earpiece to the app, the user would be able to either track their fitness or use the translating function, as seen in the mock-ups of the app user interface on an iOS device. The fitness screen displays daily step count, floors climbed, calories burnt, as well as breathing and heart rates. The translating screen would allow the user to pick from a drop list of languages and easily translate between the 2 chosen languages, and this would then be output into the earphones. Additionally, the earpiece can be used for communication between 2 users on Mars who both possess the earpiece, either in long range or short range distance. Currently, we have all of the functionalities of our earpiece attached to the Arduino, and in the future we plan to create a functional prototype with buttons. To do that, we have to first connect the sensors to the SQL database, and decrease the size of the electronic circuit for everything to be able to fit into one component. Then we will 3D print our machine-made prototype.